Hello, this is Shanko and welcome to chapter 11 of the microservices with Spring Boot tutorial. So in this chapter, we're going to learn about how we can package our applications as a single unit and run them in autonomous self-contained spaces. So when we are dealing with microservices, we might be having different components that need different versions of a particular software. So we might be having one component that uses Java 8 and that needs a Tomcat server to be run on, and there might be another static component, and then again there might be another component that is compatible with another version of Java, maybe a lower version of Java. So in that case, when we are trying to ship our application, or when we are trying to ship our software to the client has to do a prior setup, or the client has to follow a prerequisite list and get the software installed, get the required software installed on the client server before the applications can be run. So while developing, we might be using some kind of environment. We might be doing the setup on our systems. We might be having a version of Java setup done on our system, and then again the client has to do the same set of software installation procedures before the software can be run, before the software or the application that we are shipping to the client can be run. And that becomes really difficult in a microservices ecosystem, because microservices are meant to be autonomous. Microservices are meant to be independent of each other. So it doesn't matter what one service is using, what technology stack one service is using. So one microservice or one component might be using a certain set of technology stack, and that might be completely different from another service, and these two services are talking to each other via an exposed URL or as an API that can be consumed over HTTP or HTTPS or some kind of protocol. And these components are individual, they are autonomous, they are independent of each other. So it doesn't really matter what one component, what technology stack one component using to the other component. So for running both these components, the client has to do a prior setup. The client has to do a certain has to go through a certain set of installation procedures before these two components can be run on the client end. So in this case, it really becomes difficult for the client to do all those kind of setup and have all those software installed on the server before running the application. So instead of having the client to do or having the client to run these procedures before being able to run the applications, what we do in a microservices ecosystem is we package everything into a single unit. So if our application needs Java 8 to run, we package Java 8 into a single unit as the application is inside. So we package Java 8. Our application might be needing Tomcat server to run, so we package Java 8, we package Tomcat server, we package our application code into one single unit, and we ship that unit to the client, so the client can use it as it is. And something that runs on my system, something that runs on the developer system, a piece of software that can be run on the developer system should be able to be run on the client system as well, without having to go through any kind of prerequisites or any kind of software installation before being able to run the application. So what runs on one system should be running on another system, regardless of what configurations or what setup the other system has. So that is what we are going to learn about in this chapter, and we're going to use Docker for that. We're going to create Docker images for our applications, and we're going to see how we can run those images in self-contained environments or self-contained spaces, basically individual containers or autonomous containers using Docker. So if you already do not have Docker installed on your system, you can just go to this website, Docker Hub, and you can get Docker downloaded from here. And again, there are various flavors of Docker depending on the operating system and the version of the operating system that you're using. So in this demonstration, I'd be using, since I have Windows 7 on my system, I'd be using I'll be using Docker Toolbox, which is compatible with Windows 7 system or Windows 7 operating system. But that is again a legacy flavor of Docker, and there are newer versions of Docker available. So first we're going to create the Docker file. So we have already seen this application. We have already seen this product service application in our previous chapters in this series, and let's just take a look at it again. So this is basically an API. This is basically a microservice inside our microservices ecosystem. This is basically an API, a microservice API inside a microservices ecosystem. And let's just take a look at the POM first and take a look at the dependencies for this project. So inside the dependency section, we have Spring Boot Starter Web. So this application would be exposed as a web application. And then we have Spring Cloud Starter Netflix Eureka Client. We have DevTools, Spring Starter Test, OpenFean, and Netflix Historics, right? So these are the dependencies for this project, and this project is supposed to be exposed as an API that can be consumed via an endpoint. And let's take a look at the controller for this class, or for this project. Okay, so we have this /API/v1/product endpoint, and this is going to fetch us the product details, right? So a very basic application, a very basic web application, Spring Web application. So let's just go ahead and create the Docker file. So what I'm going to do is right click on this project, go to new, go to file, and I'm going to call this file Docker file. So this is the naming convention that is followed for creating a Docker file. So it's just Docker file without any extension. And let's click on finish. So in this file, we need to mention what all steps we should be running to create the image. So first we're going to say from OpenJDK :8. So this means these are the prerequisites. If I'm saying from OpenJDK, that means I'm trying to build my image on top of this image that is already present inside the Docker Hub. So what we see here is the Docker Hub. So Docker Hub is basically like a repository. It's basically like a Nexus repository, or a Git repository where we can store our code and where we can store our jar files and stuff like that. So Docker Hub is basically it provides us a repository where we can store our Docker images, and we can use other images as well. So this is one of the images that is present inside Docker Hub, OpenJDK 8, and this is the version that we're trying to use. So we are trying to package OpenJDK and the application into a single unit, and that is why we are building our image on top of the OpenJDK image that is already present inside the Docker Hub, right? And next up, we're going to say add target / the name of the jar. So I'm going to make the name of the jar as product service. So this is what we are trying to add to Docker. So this is the image that we're trying, or this is the jar that we are trying to build an image of. So the jar would be present inside the target folder. So if we do a Maven build, or if we build this project and try to create a jar out of it, it would be present inside the target folder, and that is why I have mentioned target / product service. So this would be the name of the jar, and let's say .jar, and this is what we are trying to add into Docker. So I'm going to add it to the root directory, and I'm going to keep the name as product service .jar, right? And then we are going to say expose and give a port number. So I'm going to say 8585. So this is the port on which this application would be exposed on inside the image. So inside the image, the jar would be exposed on port 8585, and I would say entry point entrypoint, and give a set of commands. So I'm going to say java, comma, dash jar, comma, product service dot jar. So when we try to run a jar, this is the set of commands that we gave, right, to run a jar from the command line. So java minus jar and then the name of the jar. So that is exactly what I have mentioned here. This is a set of commands that need to be run to start up the application. So that is basically it. And we also would need to create the jar for this project first. So first I would go inside form, and in the build section I would mention the final name as product service. So this is the name with which the jar is going to be built, and I'm going to build this application. So I'm going to right click, Maven build, and I'm going to give in the set of commands that I need to run to create the jar. So I'm going to say clean, install, and package, and I'm going to check this skip tests and click on run. So this is going to build the jar for us. So in a real-time scenario, in a project scenario, we might be wanting to use Jenkins or some kind of CI/CD build tools to build the jar out of the project or out of the application. But just for the demo purpose, we are just using the local Maven build to create a jar. Okay, the build is successful, and let's just refresh this, and let's go inside the target folder, and we can see we have our product service jar available now, right? So let's now try to create the image for this project or for this application. So all I'm going to do is I'm going to click on properties, go to the location for this project. So I'm going to copy this and go to my file explorer, and I'm going to go to this location, right, and I'm going to start up a command prompt terminal on this location, right? So first up, okay, so since we are using Docker toolbox, we'll be needing to run our commands, or we'll be running a virtual machine. We'll be connecting to a virtual machine and running all our commands, or building all our images and running all our containers inside that virtual machine. So first up, I'd say Docker machine start default. So that's going to start the virtual machine name default. Sorry, there's a spelling mistake. Now that we have started the virtual machine, we need to actually start using it. So I would say Docker machine env default, and we need to run this command. So I just copy this and paste it and hit enter. Alright, so let's first take a look at the images that are already present inside this machine. So I'm going to say Docker images, and this is going to give me the list of the images that are already present. So we can see we already have OpenJDK image present, because we had I had already created another image of another service inside this machine, and that is why we already have the image present. And now we can build the image for this application, for this product service application, right? So let's go back to our command prompt terminal, and let's run the set of commands to build the image for this application or for this API. So what I'm going to do is I'm going to say docker build, and then the name of the file, the name of the Docker file which holds the set of steps that need to be run to build the image. So I'm going to say -f, and the name of the file is docker file. So if we go back to our workspace, we can see the name of the file that we have created, which contains the set of steps, is called docker file. So that is the name that I have mentioned here, and I would need to give the name of the image that we're trying to build. So I would say -t product service. So this is going to be the name of the image that we build, and I'm going to hit enter. Alright, so apart from this, we also need to mention the path on which this Docker file exists. So since we are already at the product service folder, inside the product service folder, I just say dot, but if we were at some other location, we could have mentioned the location for the Docker file, the folder which contains the Docker file, right? So I'm gonna hit enter. And we can see we have the different steps being run. So first we have this from OpenJDK 8 being run, so that would download the image of OpenJDK that is already there. That's why it didn't take much time, but if it is not already downloaded for you, it might take a bit longer for you. And then we are trying to run the second step. So we are adding this jar, and then we are exposing this jar on this particular port, and then we are running this set of commands. So we can see we have this successfully built message being displayed here. So our image is already present. Now let's take a look at the docker images command again, and let's take a look at the list of images that we have. So we can see we have product service image present, and it was created 42 seconds ago. So it was just created. And now let's try to run this application. Let's try to run this image inside a container. So what I'm going to say is, what I'm going to do is, I'm going to say docker run, and I would need to mention the port on which I need to run this. So let's say I want to run this on 8686, and if we take a look at the Docker file, this is exposed on port 8585 from inside the image. So I would say 8585 after a colon. So that means we are trying to map 8585 to 8686. So this is already exposed as 8585 inside the image, and we are trying to choose, or we are trying to run it on a new port which is 8585, or rather 8686, right? And then I'm going to give the name of the image that I'm trying to run. So that would be product service, and I'm going to press enter. Okay, so there's a typo. And this would actually start up our application on port 8686. And we can see we have the Spring logo present here. That means our application is being run, or our application is being started inside a container. Okay, so our application is already up and running. So since our image is not present inside our local host, and it is not running inside our local host, it is rather running on a virtual machine, we actually need to know the IP for that virtual machine on which it is running. So for that, I'm simply going to type in docker machine IP and the name of the virtual machine, so that is default, and press enter. So this is the IP on which our application is hosted. Let's go to the web browser and try testing our product service API. So let's open up one tab and type in HTTP, and this is running on port 192.168.99.100, and our API endpoint is /API/v1/product. So if we go back to our controller, we can see we have the API/API/v1 and /product as our endpoint. So let's try hitting this URL and see if we can fetch the result. So we can see we have the result. We have the product details displayed here. So let's do one thing. Let's start up another container and run a product service on another container. So what I'm going to say is I'm going to do docker run -p, and this time I'm going to run it on port 8181, and it is exposed on 8585, and the name of the image is product service, and hit enter. Okay, so our product service application is up and running on 8181, and let's try hitting that URL and see if we can fetch our result. Not. Okay, so we can see we have the result. We have the product service details, or the product details, from 8181 as well. And if we go back to our terminal and do a docker ps, that's going to list down all the containers that are running. So we can see we have the container ID, and we have the image that is being run inside the container ID. We have the command that has been used to start up the application, and then we have the port on which it is running. So we have two containers that are running the product service, and they are running on different ports. So one is running on 8181 and another is running on 8686. So that is how we can basically containerize, or we can create images of our applications, and we can package all the software that is needed, all the prerequisite softwares that are needed, so all the software that is needed to run the application into one package, and ship that particular package or ship that image to the client, which can be used as it is, and the client can just run the application without having to go through the installation procedure. The client need not install the software that is needed for running the application, because everything is packaged inside the image, and the client can simply run the application. And again, this is very important for our microservices ecosystem, because we have individual containers which run instances of an image or of an API or of a service, and that is very crucial in a microservices ecosystem where we have autonomous services running independently of each other. So that is all about this chapter, and I hope you guys enjoyed this chapter, and if you did enjoy, please give it a thumbs up, and thanks for watching.